This problem of infinite series of resistance arranged in this fashion has unique way of solving for the equivalent resistance, and one must get used to by solving such problems. Here we must find the equivalent resistance between the points A and B of infinite resistance of 1 ohm arranged in such way as shown in the figure. Let us solve it. Let the equivalent resistance be Req. If we carefully look at the red dashed rectangle, the very same arrangement is seen. So it must be also equal to same Req. Now the circuit becomes this, where the red one is Req and the blue one is 1 ohm. This is easy to do. First we tackle the red one parallel to blue one. Let us call small Req. Now we should directly know the formula for parallel resistances to calculate the small Req as this. In case you do not know the formula, we do old way. The reciprocal of the small Req is sum of the reciprocal of the resistance. We get this formula for 2 resistances and should memorize it. Now, the circuit becomes even simpler as this. 3 resistance are in series and therefore simple sum of 3 resistances, and we write as this. Let us solve in the next page. When solving this equation, we get a quadratic equation. When solving the quadratic equation, we get 2 solution, a positive value, which is 1 plus square root of 3, and a negative value, which is 1 minus square root of 3. We ignore the negative value. Hence, answer is the positive value, which is 1 plus square root of 3. Let us summarize what we learned solving this problem. First lesson is to infinite such series. We see the same pattern again and can be equated to simple circuit. The second lesson is the equivalent circuit of 2 resistance in parallel is R1 times R, 2 divided by R1 plus R2. The third lesson is when we get quadratic equation, we expect one solution to have impossible value, which should be ignored. That is all for now. If you like my teaching style, give a like and subscribe. Bye-bye.